Good morning, my dear students. Welcome for today's video lecture of maths. In today's lecture, we are going to learn the laws of exponent. Okay, you know exponent means or exponential form of rational number means when any rational number is multiplied with itself again and again, right? As we have seen in yesterday's video that if 1 by 2 is rational number and if 1 by 2 is multiplied by itself with itself again and again, then this can be written in the form of exponent, exponential form. See, since 1 by 2 is multiplied here 4 times, that's why it can be written as 1 by 2 raised to the power 4. Here 1 by 2 is called as a base, 4 is the exponent or power or index. Okay, understood? So this we have seen yesterday. Now in this exponent, some patterns or some laws are observed. Okay, which are those laws? While performing operations over rational number with the exponent, okay, some laws are discovered or some laws are established. So which are those laws and how those laws are going to be useful here while solving the examples based on the exponent of the rational numbers? Okay, see, your first law is when a upon b is a rational number and m and n are integers. M and n are integers. In that case, a upon b raised to m into a upon b raised to n is equal to a upon b raised to m plus n. Understood? Means what? A upon b is a rational number and this m and n, which are exponents here, they are integers. In that case, when a upon b raised to m into a upon b raised to m, in both these rational numbers, the bases are same, a upon b, where the exponents are m and n different. And which operation is there? Multiplication. So we can say that when bases are same and there is multiplication, at that time the exponents get added. Okay, this is first law. For example, suppose 3 by 4 raised to minus 2 into 3 by 4 raised to minus 3. So this how this example can be solved. Okay, so here we can use this rule. Base is same and there is multiplication, that's why the exponents will get added. Okay, so here 3 by 4 write as it is, and the exponents minus 2 and minus 3 will get added. Okay, that is 3 by 4 raised to the power minus 2 plus minus 3. Okay, that is 3 by 4 raised to minus 5. So in this way, this example can be solved using this first law. Wherever you will observe that bases are same and there is multiplication, immediately what you have to do? You have to add their exponents. Okay, add their exponents like we have done here. So this is the first law. A upon b raised to m into a upon b raised to n is equal to a upon b raised to m plus n. Okay. Second law is same, instead of multiplication there is division. So if when bases are same, a upon b raised to m divided by a upon b raised to n, when bases are same and there is division, in that case what happens with the exponent? Exponent gets subtracted. Okay, see here, a upon b raised to m divided by a upon b raised to n is equal to a upon b raised to m minus n. Understood? Exponents are subtracted. For example, if you want to take, for example, 7 upon 8 raised to minus 5 divided by 7 upon 8 raised to 7. Okay. So here, if you see bases are same, 7 upon 8, 7 upon 8. There is division between them. So in that case, what we have to do? 7 upon 8 raised to exponent get subtracted. Minus 7. That is 7 upon 8 raised to, now minus 5 minus 7 means minus 12. Correct? So this is your answer. Okay. Next. Third law. See a third law, a upon b raised to m bracket raised to n. Power of power, exponent of exponent. See, first a upon b, this rational number has exponent m. Again, this has exponent n. That is called power of power. A upon b raised to m raised to the power n. So in this case, what happened? A upon b raised to m into n. In that case, this first exponent and the second exponent both get multiplied. Okay. For example, if you want to take example, we can say that, see, suppose minus 3 upon 5. This is suppose rational number and it has power 3, and again second power is minus 4. Okay. So how to solve this or such example? So here, if you observe, there is power of power. Okay, that's why minus 3 by 5 raised to, in such examples, these two powers, two exponents get multiplied. So 3 into minus 4. Okay, 3 into minus 4, that is minus 3 upon 5 raised to 4 3s are 12 and plus minus minus. Okay, so minus 12. Understood? So these are the first three laws. I hope you have understood this. Pause this video and write these laws along with the example in your notebook. We will see next laws. Okay. See now next law number 4. A upon b raised to m into c upon d raised to m. See here, bases are not same. Bases are different but exponents same. Okay, m. Okay, in that case, when bases are different and there is multiplication and exponents are same, at that time what happens? Exponent take it common. Exponent take it common and these two bases will get multiplied. Understood? Understood what happened here? See this law, when bases are different and exponents are same, and while there is multiplication, at that time these bases get multiplied while exponent will be common for them. Okay. For example, see here, if there are two rational numbers, 1 by 2 raised to 2 into 4 by 3 raised to 2, means what here? Bases are different but their exponents are same and there is multiplication at that time. At that time, these bases get multiplied. 1 by 2 into 4 by 3, while these exponents, which is same for both of them, will be taken as a common. Okay. Now do this multiplication. 2 1s are 2, 2 2s are 4. Okay. 2 1s are 2 here, and upon 3 1s are 3 raised to the power 2. This will be your answer. Okay, so this is our law number 4, which tells us that when bases are different but their exponents are same in the multiplication, at that time bases get multiplied and the exponent will be taken as a common. Okay, then see law number 5. It is very important law. It is very important law in this standard we have to deal with. Okay, why? Because see, a upon b raised to negative n. It's negative. Exponent is negative. So if you want to make it positive, this law tells us that when any exponent is negative, how to make it positive. Okay. So here, when a upon b is a rational number and its exponent is negative, how to make it positive is very simple. It's very simple what to do. Write the multiplicative inverse of this rational number, reciprocal of this rational number, and automatically this exponent becomes positive. See, a upon b raised to minus m is equal to b upon a, reciprocal of this. Okay, b upon a raised to positive m. Okay, so these a upon b raised to minus n and b upon a raised to n are equal. Understood? Means what? First, let me tell you that how it becomes positive. See here, a upon b raised to minus n. This means that this minus n belongs to both the numerator and denominator. Okay. Now last year we have seen that a raised to minus 1 is equal to 1 upon a. Means what? This a has been taken in the denominator at that time. It's minus 1 integer becomes plus 1. Means here a means a raised to 1. Understood? So here also we have what we have to do. This a raised to minus n we have to take in the denominator. So it becomes a raised to n, and b raised to minus n which is in the denominator we have to take in the numerator. So it becomes positive integer b raised to n. So it becomes b upon a raised to n in this way. Okay. So any rational number with negative integer, if it is asked to convert into positive integer, what we have to do? We have to write its reciprocal. We have to write its reciprocal. Understood? Okay. This is very important law. Very important. Okay. Now see law 6. This law also we have seen in the case of integer. We have seen that a raised to 0 is equal to what? 1. And why it is 1? That also we have seen. Again, I will show you why it is 1. See here, a upon b raised to 0 is equal to 1. As we have seen, we are dealing with the rational numbers, exponents of rational numbers. So we have to take here rational number. Okay, so a upon b is any rational number. Why a upon b raised to 0 is equal to 1? Because see here, when any rational number will have exponent 0, see a upon b. Suppose a upon b raised to 5, a upon b raised to 5 divided by a upon b raised to 5. Bases are same and their exponents are also same. In that case, what will happen? A upon b raised to 5 minus 5. That is a upon b raised to 0. This is according to which law? According to second law, which we have seen. Okay. So 5 minus 5 0. But again at the same time, if a upon b raised to 5, that means 5 times multiplication of a. So a upon b into a upon b into a upon b into a upon b into a upon b. Divide by again a upon b into a upon b into a upon b into a upon b into a upon b. Okay, a upon b raised to 5. Now what happens here? A upon b 5 times. Okay, since there is division by this, so division means what? Multiplication by the reciprocal. So write reciprocal of all these, b upon a into b upon a into b upon a. Now see, this b cut for this b cut, this b in the numerator will cut. Similarly, a in the numerator, a in the denominator will be cut. Okay. So what remain at the end? Remain 1. Same example. See, a upon b raised to 5 divided by a upon b raised to 5. Same example. In same example we get two answers. A upon b raised to 0 and 1. That's why a upon b raised to 0, this is equal to 1. Okay. All the time remember this. A upon b raised to 0 is equal to 1. Okay. So this is law number 6. Again, pause this video, write this 3 more law in your notebook. Okay. And so students, today we have seen or we have learned the 6 laws of the exponent. Okay. So after watching this video, what you have to do? You have to solve question number 1 to 4 from exercise 2A. Okay. Question number 1 to 4. All the examples from question number 1 to 4 of exercise 2B. Okay. Not 2A, 2B. Okay, so thank you for today and have a good day.